Okay, hello everyone. So in this video, I'm going to show you how you can easily transfer your data from a Google spreadsheet into Desmos and create a nice graph of your data with error bars. So here we have the data that we looked at in class. We've been rolling a tennis ball down a slope. We changed the distance that we rolled the tennis ball down. So we have our independent variable there. Then we took 5 trials of the time values, and we've calculated the average over here, which is what we want to graph. You don't graph individual trials. And then we also calculated the uncertainty of the average, and you can see we get different values for different rows, so that's also important to include in our graph, as we'll see. So you start off by selecting the relevant data, okay, our independent variable values, our x values, and then our average values, our y values, and the uncertainties of the y values. Command C, copy, go into Desmos, and you Command V, paste your data in. Now Desmos thinks that you want to plot the uncertainty in this strange way. We don't want to do that, so just uncheck that. And now we're ready to add error bars. You can see there's a definite trend that we want to investigate here. So the way you add error bars is relatively easy, a little bit technical, but here it goes. The vertical error bars, okay, that's the uncertainty in the time. By the way, let me just show you how you can very quickly label the axes as well. So if I just go back here, so distance here is, I can just copy, paste that header, and then I just go in here and I paste that in. So I've got my distance label on the horizontal axis, and I can go in and I can just copy paste that column header in here, and then I have labeled my axes nicely. Okay, so vertical error bars, like this data point is the 0.56 seconds, it's plus or minus 0.03. So I'm drawing some vertical lines. I can draw vertical lines through all the data points by just writing this. They're too long, those vertical lines. I need to restrict them to being just plus or minus the uncertainty. So I write that as saying y1 minus the uncertainty until y1 plus the uncertainty. So those who are good at math, you can easily understand the logic here. I'm just restricting my range to be within z1 of y1. And then you get nice error bars on all your data points. Okay, so horizontal error bars is the same idea. Now I'm just drawing horizontal lines, and I need to restrict the domain. What was the uncertainty of the distance measurements? We estimated that to be 0.5 centimeter for all data points. So, that value is not different for different values like it was for the time values. So here I can simply just write minus 0.5 and plus 0.5. Sometimes if you have a constant percentage uncertainty, you can also just use your knowledge of percentages to easily draw error bars here. Okay, so there we have it. Nice error bars, vertical and horizontal error bars, and they each sort of define what I call a window of uncertainty. So this data point could have been anywhere within this large window of uncertainty. So when we, in our next video, look for a mathematical model that fits the data, then the graph we draw just has to go through that window of uncertainty to be accurate. Okay, see you in the next video.